Let's go back to our original plan of finding antiderivatives. The main rule that we want to work with is that we add 1 to the exponent, then divide by the new exponent. And this applies to radicals. Yesterday we talked about using the distributive property to write things as a sum of powers of x. And so we are going to do the same thing when we have radicals. And when we see radicals, we want to get rid of the radicals and replace the radicals with fraction exponents. So radicals are some kind of old notation. I don't know what we were thinking when we came up with that. But eventually we figured out we could do rational exponents instead of these radicals, but the radicals hang around. It's so traditional and it's kind of annoying. But anyway, let's look at an example. So if we want to calculate or find the antiderivative of, let's say the square root of x dx, our strategy is to rewrite the square root of x as an x to the 1/2 power. So now we can apply our rule where we add 1 to the exponent and divide by the new exponent. So now we can write this as x to the 3/2 and then divide by 3/2 and make 2/3. Plus c, of course, because we don't want to lose a billion points. And that's what we wanted to add to our list of finding antiderivatives. We want to add 1 to the exponent and divide by the new exponent when we're dealing with radicals. If the radicals appear in the denominator, we don't automatically natural log things. Natural log is only for x to the -1. Not just anything in the denominator. So, super dangerous trick question. If I give you the integral of 1 over the square root of x dx, the true trap is to put this right after the integral of 1 over x. So the integral of 1 over x is natural log of x, so the integral of 1 over the square root of x, the trap answer is for you to write natural log of absolute value of square root of x, but you don't want to do that. Because when you can write powers of x, then you should. The exponent here is not x to the -1. This is x to the -1/2. So we just apply we write as powers of x. This is an x to the -1/2. So we do the same thing. We add 1 to the exponent. -1/2 plus 1 is 1/2, and we divide by the new exponent. We add 1 to the exponent. -1/2 plus 1 is 1/2. Just like up here, 1/2 plus 1 is 3/2. Then we divide by the new exponent, which is multiplying by the reciprocal. So the integral of 1 over x is natural log of x, but 1 over some other power of x, write it with a negative exponent. Questions? That's pretty much it. We want to make sure that we write powers of x when we can. So the 5th root of x to the 3rd is x to the 3/5 dx, where we add 1 to the exponent, so 3/5 plus 1 is 8/5. So I'll have an x to the 8/5 and divide by the new exponent, so 5/8. And as usual, just because stuff is in the denominator, it doesn't mean that natural log of x shows up. So if I have the integral of 1 over the 5th root of x to the 3rd dx, we're going to integrate x to the negative 3/5 dx. And in this case, negative 3/5 plus 1 is 2/5. So we have x to the 2/5 times 5/2 plus c. Any questions? How's everybody, okay? It's weird. Zoom was acting up so much yesterday, but today's Friday the 13th, and it seems to be going fine. Although now I've jinxed it. All right, let's pause the video here and talk about what's coming next.